Okay, so we're going to use calculus to find this point that's closest to this this line, and so we need to know the distance formula. Distance is the square root of, and we're going to be going the distance from that point, so we'll just cut to the chase here and do x minus 9 squared plus y minus negative 4 squared. And so the idea is that we have this point, 9, negative 4, and then we have this line, but this is just a generic point on the line. And we're doing the distance between them. Anyway, instead of computing, dealing with that radical, it turns out that if the distance is minimized, so will this, if we square the distance. And then we can replace the y with that. And so I'm going to minimize this. X minus 9 squared plus 19 plus 3x plus 4 squared. And instead of squaring these and dealing with a bunch of nasty algebra, I'm actually going to just do the derivative using the chain rule. And that's going to make life a heck of a lot easier. So let me just simplify this slightly. 23, I believe it is. Okay, so f prime, using the chain rule, I get 2 times x minus 9 plus 2 times 3x plus 23 times 3. So the chain rule just says you do the derivative. Hopefully that makes sense. It's also called the power rule. Some people just think of that as a special rule all unto itself when you have a function raised to a power. Okay, so I've got this. I want to find critical numbers, so I'm going to set this equal to 0. Now I have to do some algebra, but it's not bad. 2x minus 18, 6x, I almost forgot the 3 there. 3 times 2 times 3, that's 18x. Oof. 6 times 23, what is that going to be? That's going to be 144? No, it can't be 144. Hold on a sec. 6 times 23. Okay. 138. Yeah, that makes sense. 138. Okay, so that has to equal 0. So what are we left with? 20x plus 120. Isn't that convenient? Someone thought through this problem carefully, and that would be me. Okay, so 20x is negative 120, and x is negative 6. That's our critical number, but we have to make sure that that's a minimum. So is this a minimum? Well, let's find out. I'm going to use the first derivative test. So first derivative test. I've got negative 6 here. And I know that f prime of negative 6 is equal to 0. Let me move this down just a bit, make myself a little bit more room. So I know that f prime of negative 6 equals 0. What about f prime of something less than negative 6, like a negative 10? Well, f prime of negative 10 looks like that's going to be negative 200, negative 80. So this is decreasing over here. And then f prime of something like 0 is equal to 120, so this is increasing. Less than 0, greater than 0. Let me separate these a little bit. Okay, there. So since this is decreasing then increasing, this will be a minimum. But we're not done because we want the point. And so a point is going to be an x and a y. So to find the y, let's just plug that -6 into this. 19 plus 3 times -6, which is equal to 19 minus 18, which is 1. And so the final answer is -6, 1. You need both of those along with this justification in order to get this thing right. All right, now we're going to be doing the dreaded related rates problem. We have sand being dumped continuously into a conical pile at 3 cubic meters per second. So here's the situation. Sand. Okay, whatever. That doesn't look very good. There. Sand is going there. Anyway, we're told that the height of this pile is, what does it say? The radius is exactly half the height. So the height is 2 times the radius. So this is the radius here. And it says that we know that the volume of a cone is 1/3 pi r squared h. And so the volume of this cone is going to be 1/3 pi r squared times 2r, which is 2/3 pi r cubed. We want to know what's happening at the moment when the pile's height is 10 meters. So let's find out. So the pile's height is 10, which means the radius is 5. We're told that dv over dt is equal to 3. That's that 3 cubic meters per second. And so if v, let's do this. If v is 2/3 pi r cubed, we know that dv over dt is 2/3 pi times 3r squared dr over dt. Now, what are we looking for? What rate is the radius? Okay, so we're looking for the radius increasing. So we're looking for dr over dt, thankfully. Okay, let's plug in what we know. We're going to plug this stuff in up here. So 3 is equal to 2/3 pi times 3 times 5 squared times dr over dt. And that means that dr over dt, let me clean things up before, I know you guys don't like it when I do algebra too quickly. So this is going to be 50 pi, I think. So cancel the 3's. 5 squared is 25 times 2 is 50. So dr over dt ends up equaling 50 pi over 3 meters per second, which is quite a large, that is very fast. Well, there it is. Yeah, I think that's it for this one. Final one. Okay, so this we're using differentials for. We're given that the pressure is systolic blood pressure is 12 times the square root of 44 plus m. And don't go show this to any actual medical doctor because I just made that up, all right? Anyway, I'm going to use differentials, which dp, do the derivatives, and just put a d, so is equal to 12 times, I'm going to use the chain rule. So I need to multiply by 1/2 times, I guess that's just 1 there. Okay, and then I have to multiply this times dr. Let me clean this up just a bit. Make this 6 over the square root of 44 plus m. And, oh, not dr. What am I thinking? It's dm. I don't know why I was thinking r. I think I was still thinking of that previous problem with the radius of that cone. Okay, it says that the mass is, I'm decreasing my mass from 100 kilograms to 98 kilograms, which means that dm is equal to -2. And I want to know what's the predicted amount, what's the predicted outcome for dp. Okay, the mass is starting at 100. Okay, so we have, let's see, I'm going to shove this stuff in there. So dp is 6 over the square root of 44 plus 10 squared times dm, which is -2. Okay, now we have to actually do some arithmetic in our heads. I think we can handle this. 10 squared is 100. 100 plus 44 is 144. I guess we'll call this -12. -2 times 6. Now, if you really can't do the math, just leave it like this, box this up, and you'll get it right. But it's too tantalizing for me not to do this. Square root of 144 is 12. Cancel the 12s, and I get -1. What is that? Millimeters of mercury? It doesn't say. It just says pressure. Okay, well, it's -1 unit, whatever those units are. And that's it. Don't forget to smash that like button.